Hi, you guys. I have a different hat on. It's not that exciting, but it's very old. And it's like sewn with straw or plasticky. And anyways, thought I'd wear it. Doesn't match my blue shirt, but whatever. All right, let's start. We have got factoring a sum of squares. So I'm going to remind you, the square root of -1 equals an imaginary number. I squared equals -1. So what I'm going to do, let's just first go through this together, okay? How can you factor the expression x squared plus y squared? So I'm going to rewrite x squared plus y squared as a difference of two squares. Because see the double negative? X minus -y squared. How can -y squared be a perfect square? You can think of -y squared as -1 times y squared. And since -1 equals I squared, -1 times y squared equals, because -1 is the same as I squared, so I squared times y squared. So what we're going to do is I'm going to have this number, like x squared plus y squared. And I'm going to then make a difference of squares, a minus, because in here, I squared is a -1. And a -1 would have like x squared minus, think -1 times y squared, right? This then ends up being a plus, which is what I started with. So watch me do one of them first. Okay. 9x squared plus 16. Here's what I got. 9x squared minus, now what's 16? It's a perfect square, 4. But I don't want to write -4. I want to write -1 times 4 squared. They're like all together. But let's just write an I. 9x squared minus 4i squared. Okay, I'm going super slow. 9 is a perfect square. 4 is a perfect square. 3x plus 4i, 3x minus 4i. Difference of two squares. Using imaginary numbers. That's our goal today. That's what we're doing. 8x plus 72. Okay. First of all, guys, find a GCF. Because 72 is not a perfect square. 8. Factor out an 8. X squared plus 9. Okay, ready? I'll go super slow again. And on the back side, I'm not going to go slow anymore. Ready? 8 times the quantity. X squared minus -9. It's like, then, ready? 8 times the quantity. X squared minus -1 times 3 squared, right? Because 3 squared is the 9. -1 makes it -9. 8 times the quantity, x squared minus 3i squared. Isn't I the same thing as -1? Right? This then is 8, and then I'm going to factor this. It's a difference of two squares. X plus 3i, x minus 3i. Okay, so take a look at it and look at it closely so that you understand how I went from here down to here. Sorry. Okay. Now I'm going to try and solve a quadratic. So now it's going to be equal to 0. So take a look at what I did. The 4, x squared plus 4. The 4 became minus 2i squared. And then I had my difference of two squares. I solved, set them both equal to 0. This is the zero product property. And I solved. Let's try number 3 and 4. X squared minus 6i squared. So x plus 6i, x minus 6i equals 0. Set them both equal to 0. So I'm going to do x equals negative 6i, x equals positive 6i. Next one, 4x squared plus 25. Four x squared, we're going to do the same thing that I did in the last ones, 5i squared. 4 is a perfect square, 25 is a perfect square, so it's going to be 4 is 2 times 2, 2x plus 5i, 2x minus 5i equals 0. And then I solve each one for 0. So this is going to be minus 5i. 2x equals negative 5i. I'm solving for x. Divide by 2. Two x minus 5i equals 0. Add 5i to both sides. 5i divided by 2. Positive 5i divided by 2, negative 5i divided by 2. I want you to try the challenge. And remember, there's a GCF. So I want you to try the challenge number 5 on your own. Don't forget about that GCF. Okay, so this is our notes today. Super kind of not too shabby, right? All right, you guys. I will see you in class tomorrow. Have a good evening. Bye.